Hello all. Today we're going to be looking at how we can do fractional first principles questions. So what I mean by this is we have a function like this where there's a clear fraction bar and we need to be able to use first principles to be able to work out the slope of the tangent at say x equals 5 for example at a given point. So first off, because there is a lot of complex algebra involved with actually using a fraction in first principles, we're going to need to be able to do a check using the quotient rule to make sure that we get the correct answer. So, the quotient rule is given as the f of x over gx. The derivative of that is going to be the f prime of x times the gx plus, and then we have g prime of x, or sorry, it's actually take g prime of x, and then f of x on m. Sorry about that, but it's actually take. Just want to make sure that's nice and clear there. And that's all over just gx as a normal term squared. So now that we have this, let's just run through it using our equation here to make sure that we are able to get the correct derivative when we actually do our first principles problem, because we'd hate to actually have some of the terms that we use in first principles be incorrect and then get an incorrect answer because of it, because there's going to be a lot of expansion, a lot of simplifying going on. So now, if we go in there, we have f prime of x. F prime of x is 4x plus 1. So what we do here is we have that's x to the power of 1. So we move that 1 down there, so it becomes 1 times 4, which is just 4. And then the x disappears because that becomes x to 0. Again, the product rule, in case you've forgotten, is when we have a term like x to the n, or ax to the n, because we have a coefficient, we bring down the exponent to the actual coefficient, multiply them together, get the product, and then we take 1 from the exponent. So that's what I've done here, and I've just gotten 4, because x to 0 is just going to be 1. And then, of course, the derivative of a constant is always going to be 0, so we just move on. And then we have gx as it is, so we have x take 2. And then we subtract, and it's always good to use brackets here so you don't get confused. And we subtract the g prime of x. So let's have a look at what's happening here. That's x to the 1. We bring the 1 out the front, so that's just going to be 1 there. And the 2, the derivative of the constant is always 0, so it's just going to be the equivalent to 1. So I guess you can really put it in if you want to. You don't have to, because you're just going to multiply it by f of x, of course. So now that we've got that, we're going to have to expand. So we get 4x minus 8, and then we subtract, because remember we've got a negative in the middle, and we've got to remember that this is all over gx squared, which I'll do in a second, but we'll just focus on the top line for a moment. So we have 4x take 8, subtract 4x, subtract, and then we have 1. So, and that's all over gx squared. So what is gx squared? Well, it's just this term here, x take 2 squared. Now that we've done this, we can cancel out those terms because 4x take 4x is also going to be equal to 0. So we're left with negative 8 take 1 over x take 2 squared. And I'm going to expand this just for simplicity purposes. So we use FOIL here, common expansion technique. And we get x squared minus 2x plus 4. So that becomes minus 4x there. So we have x squared minus 4x plus 4. Okay, so that's really good. And what we can do now is we can substitute in 5 as x, and then we'll know what we're actually looking for the slope of the tangent for when we actually do our first principles in fractional algebra. So, I've got negative 9 over, and we'll substitute in 5 there, so if that's 5 squared, it's going to be 25, right? And then take 4 lots of 5, so if we put 5 there, that's going to be 20. And then plus 4. And then we can simplify this down, so 25 take 20 is going to be equal to 5, plus 4 is going to be equal to 9. So we're left with, and I'll write the answer over here, because I'm sort of running out of board space, but it's going to be even worse when I go through first principles for this. But our answer is negative 9 over 9, which is just equal to negative 1. So if we do our first principles correctly, which is what we're about to do, then we should be able to get negative 1 as the answer for the slope of our tangent line. Okay, so what I'm going to do is I'm going to erase the board now, and after I've done that, I'm going to show you how we substitute in figures and solve for first principles. However, I know that this is going to take a decent amount of time, so what I'm going to do is I'm going to just write up the formula, explain a bit about what I'm going to do, and then I'm going to have to stop the video because this is going to have to be a two-part video. So, I'll just erase this off, and we'll just keep in the back of our minds. It'd probably help if we actually had the equation up there on the board as well. So 4x plus 1 over x take 2 at x equals 5. Just so we remember it. And we remember that our slope of the tangent is meant to be negative 1. And then let's go through and see how we'll solve using first principles. So, our first principles equation is that the limit as h approaches 0, and this is for f prime of x, our derivative, and we get the f of x plus h, take the f of x, all over h. And what we're going to do, I'm just going to explain it briefly for those who haven't done first principles. For those who do understand first principles, then feel free just to skip to the second part of the video, you should be able to find it. But what we're going to do is we're going to go through our equation, and wherever there's a x in it, we're going to do x plus h. We're going to substitute in x plus h into that small part of the equation. So it'd be 4x plus h plus 1 divided by x plus h take 2. And then we just subtract it from the function as is, and it's all going to be over h. So in the next video, again, I'm going to go through this. I'm going to show you how we can deal with having a fraction bar there, because we're going to have a multi-layer fraction. Things are going to look a little bit freaky, but after that, we should all be fine. So see you in the next video, and part 2 coming soon.